Hello, everybody. This is Martinas Volkunas, and welcome to our last session of the year in 2020. So, thank you for everyone for joining. And it was a very interesting year for all of us. I hope that everyone stayed safe. But we had amazing events and amazing meetups and amazing presenters coming to our meetup and sharing their ideas and the knowledge with the community. So I'm really grateful to have all of you guys that participated in the events, and as well presenters who shared the knowledge. So after this meetup, we are going to meet next year, and 19th of January, we have aligned the introduction to IoT projects. This is going to be the first IoT project meetup on our UK cloud infrastructure, so slightly different. The presenter is going to be Christopher Maneo from Microsoft. And today we are recording the session, and as usual, we are going to host it on our YouTube channel, which is UK DevOps Collective. And as well, we are running the small initiative where you can buy the coffee at buymeacoffee.com/UKCloudUG user group, where we buy a coffee for the presenters for preparing awesome content and spending evenings, mornings with us, sharing great content. And today's guest is 11 times Microsoft MVP, and we already had our guest back in 2018, where he talked about the advanced deployment patterns. And as you can guess, he is a regular speaker at conferences and meetups, and he's really passionate about Agile, ALM, and DevOps. As well, he's running the London's Microsoft DevOps meetups, where you can find lots of interesting sessions there as well. So, Matteo, pleasure having you with us tonight, and thank you for being with us today.
Well, great to be back, Martinas. I can't believe it's 2 years since I spoke last at your meetup, so absolutely great to be back. Can't wait to get going.
So we know that you prepared some great session today. So shall we start?
Yeah, let's crack on. So let me share my screen. Okay. So you should all be able to see my screen. Welcome, everyone. And the session is cheekily enough entitled "How to Make Security Pervasive Without Falling into the DevSecOps Trap," because everybody today is talking about DevSecOps. Everybody's talking about shifting security left back into the developer realm. That's brilliant, but it is a trap, and we will see how. First of all, let's think about what DevOps is. So the definition that I usually use is Donovan Brown's. So DevSecOps is the union of tool, process, and people to ensure continuous delivery of value to our end users. In all of that, tell me where security is. The answer is security is already there, because we don't need another definition for DevSecOps. At the end of the day, we don't want to end up in a world where we have DevSec beats cloud, whatever ops. We just need to work with tools, process, and people, or people, process, and tools, depending on how you want to say it, non-labels. DevOps on its own already covers the security piece. It's just up to us bringing it forward, bringing it center stage, and making sure that it is a first-class citizen. There are two fronts to work on. The first one is the shift left, so moving the security problem back into the development space. That's very important, because the sooner you tackle security, the cheaper it's going to be for a team to actually work on it. It's also very important to ensure that the team agrees, when the team is well aware of this shift, so that the cultural shift is digested and it is accepted by all the team members. Security should be a major requirement when considering a user story, not just some afterthought or some option to configure when it comes to your feature. It should be well thought about. It should be treated as a requirement on its own, and it should be treated as something as important as the functionality. But you should also provide tools to development teams to address issues as early as they come. Again, that's a problem that it's tackled from a technical debt side, but also from a cost perspective, and we'll see that in a moment. But having tools is extremely important, because if you need to fix a problem, then it's important to have all the tools that you might want to use for it. On the engineering practices side, it's important to integrate lightweight toolkits that are going to help bringing information at the front. So rather than having once a year pen tests and security scans, doing those operations in a lightweight fashion over the course of the whole development is going to bring massive benefits. Considering security as a first-class citizen means that you don't just leave everything open on the network, but you think in advance about what your application might require. You will think about what are the connectivity methods that are required, the ports that are required, or the settings that your application might be using. And then you will have a process that enforces the best practices. So breaking the build, if you have, let's say secrets in the code base, or having a scan about your infrastructure, both definitions and environments. So things like that, those are very important. Then if you bring them in as practices, they just become the habit. Shifting left is the same story that we saw with unit test, TDD, and so on. In short, the sooner you tackle the problem, the cheaper it is. And it's as simple as that. So this is a very well-known chart that talks about the relative cost of fixing bugs based on the time of detection. You can definitely see that if you spot a bug at requirements time, when you're still discussing it with the stakeholders, when you're still analyzing the problem, is going to be up to 30 times cheaper than fixing it once it's been released to production. Now think about it. Security problems like having databases exposed, SQL injection, or even just the denial of service, that's going to be way more expensive to find out when it's in production rather than at systems testing, at acceptance testing, because obviously once you have live traffic and customers coming in on your application, every moment of downtime is going to be expensive. So there's no way around it. And the sooner you can find problems, the better it's going to be. On the engineering practices side, it's a little bit more complex because we now have so many tools that we can introduce into our pipelines that we're very much overwhelmed by the choices that we have. So it's important to integrate a security toolkit as part of the CI/CD process, but it's important to add it in the right places. So by the same shift left principle, a problem during CI is cheaper than something found in a release candidate during, functional testing, for example. So CIs are extremely important because you can fill them to the brim with tests and checks, but if you have a security issue, you're not going to be able to spot anything. So you need to think about the impact of your toolkit on the CI stage, which, remember, should be nimble, should be fast, compared to the weight later down the road. You can do it at every corner, effectively. You can do it at every step of the way, but you have so many places from where you can integrate security that it becomes a little bit overwhelming when it comes to think about security. Security is a foundation, right? It's not just the lick of paint on the front of the house. It's one of the most important things that are going to underpin your application or your system. So it should not be an afterthought. It should be something that starts with the developer. And it always starts with the developer. It is looked by the engineering practices, but at the end of the day, it all starts with the developer and the requirements. Like I say, it's always an interesting day, because if you think about it, you start with the developers, then you build, package, ship, and operate. Hence, you need a holistic approach on that. On the development and requirement side, obviously having quality tools and metrics within the IDE is extremely important. DevScim is an example of bringing security into the IDE. Then you have facilitators like Key Vault for connected services. So rather than storing your secrets somewhere, wherever that is, you will have a place where things will be secure, and they will also be consumed in a secure way. That's a game changer when it comes to environments. Moving on, we have things like SDL, so Security Development Lifecycle. It's a long time methodology. It's been around for a long time, and now concepts from SDL are brought into agile methodologies because you can do threat analysis in Scrum. You can do threat analysis as part of any other agile methodology. Nobody's stopping you from doing threat analysis, so you should definitely integrate it into your current process. Security should be a first-class citizen anywhere. When it comes to building, then you start looking at things like software composition analysis. So all of your dependencies should be scanned and identified with tools like WhiteSource. Having code quality scans with tools like SonarQube Q1, just to understand if you have well-known patterns of technical debt. And then having static security testing as part of your build with lightweight things like Beanskim, or potentially something heavier like Fortify or Checkbox. On the packaging side, having infrastructure as code security validation is key, both on the definition themselves and on the environments. So an environment can always be checked against a well-known baseline in case there is something that doesn't work as expected or has been changed manually and have no trace of it. Doing dynamic security testing is extremely valuable because it is testing your application against a well-known series of vulnerabilities, and it's going to test your application running in anger. And eventually, never forget the good old malware scan, because whenever you package something, you might not know that you have malicious code in there. So if you run a malware scan, chances are you're going to find something if there is something malicious. And eventually, monitoring. So continuous monitoring, you should look at as you monitor. You should look at all the solutions for telemetry. You should look at things for continuous assurance to check for infrastructure drift. And that's something that you can do also as part of the deployments here. So you do continuous assurance, you check your environments for drift. And eventually, learning from incidents and reports. That's extremely important. An incident or a problem should not just be something that happens, it is fixed, and then it is forgotten. It should be something that you can learn from, and it goes into your backlog so you can improve continuously on what you do. So there is so much that can be done. There is so much that can be done on the development front, the engineering front, the monitoring front. So let's take a look at a few examples on how to build your toolkit. I will keep an eye on questions here on my right-hand side screen. So if you want to, ask anything, just feel free to ask, and I'll be taking a look every now and then. So let's take a look, first of all, at some code. So this is a traditional example of where the IDE is going to come in handy. In this specific piece of code, which for whatever reason is not initialized correctly, so let's scan all the files. Interesting.
Matteo, can you zoom in maybe a little bit in the code, please?
Yep. Is it any better? Whatever reason, of course.
Yes, thank you.
Not to work. If you use a tool like DevSkim, which is something that I was trying to do, in this case, you should see a warning over here. But unfortunately, the extension is not loading. Let's try that again, just to be on the safe side. Okay. Interesting. It's not showing. So DevSkim is a tool that is going to scan your code and is going to provide recommendations for what is the best practice. In this case, for whatever reason, it is not recognizing this C# file, and it is not recognizing that I have an MD5 hash being created here, which is obviously weak. I should have had, no, it is not working for whatever reason. But you need to install DevSkim in Visual Studio Code to ensure that this demo works compared to mine. And then you should have a tooltip over here that's going to tell you, look, you have a problem here. You should try to fix it. Let's try to reload the extension once again. I'm trying to reload them all. Just on the safe side. Don't need to build. Yeah, it is not loading. It is not loading. So in general, if you search on the DevSkim project, so let's open that up. This is what's going to happen. So whatever you're going to use, you will have recommendations provided by DevSkim itself, so that you can get the most secure code directly from the IDE rather than creating it, having it fixed, after ACI failing. Let's take a look if there is the actual example that I usually use. I'm sorry about that. It was not expected. So this must be the one. Very annoying. So this is an example in Visual Studio where you can also ignore your rules. So even if you get the prompt, then you will have the possibility of ignoring it. But unfortunately, it's not really showing. Yeah, this is the code I was going to use. So in DevSkim, you will have the possibility of changing the MD5 reference with an SHA 256 reference, so that it's going to be more secure rather than using a weak algorithm. That is DevSkim scanning, in this case inside traditional Visual Studio. It's going to scan for the code, and it's going to identify an MD5 reference, so it's going to be changed to the right hashing algorithm. Unfortunately, I can't show you that. I can show that to you. It's not loading at all, and I have no idea why, if I'm fully honest. So this is exactly the same code, but it did not load in this example. Again, this is something that runs from the IDE. So it is something that runs from the IDE. So you will have this information directly when writing code. A good alternative would be Sonar Linked. That's another tool that does the same thing, and it will give you recommendations directly into your development environment. Another thing that I really recommend using is Key Vault. So like we discussed, Key Vault is extremely important when it comes to developer helpers. So something like this is going to help you a lot. So Key Vault is going to store your secrets in a secure way. So what you can do, rather than storing them anywhere and then encrypting and anything, you can store all your secrets in there and then map the secrets directly to a variable group in Azure DevOps. What is going to happen is that you will have a variable group that's going to be connected directly to Key Vault, and then you will be able to import anything that you need directly from here. So in this case, I only have one variable that I already mapped, but if I had more, I would have been able to choose any variable that I could need. Once you map them, those will be directly mapped to variables inside Azure DevOps, so you will be able to consume them. And the cool thing is that whatever you do, those are going to be encrypted. So I wrote a small script about it where I can do some validation with an input key and a control key. So I can check for the status of, the value of the control key against the well-known, against the secret, and then I can see if the value matches or not. If I run it, even if I run it successfully here, so I'm not going to run it directly just for the sake of time, but if I run it, and the way that I run it, by the way, is as simple as that. So I have a control key that is, this is my key, and another key that's, this is not my key. Obviously, the value of the secret is, this is my key, and that is in a definition that looks like this. So fairly simple. I just call the PowerShell script. I have nothing else for it. It's a very simple demo. But it shows that whenever I run this, I can validate my key, but my key is never, is never shown in the clear. Even if the command is effectively just a PowerShell script, it's nothing fancy, that value is never shown. Instead, if I start looking at a failing one, where the input key doesn't actually match, you will also see that, yes, this is not my key, is in the clear because it's identified as not being the secret, but also because this value over here, which is this is my key, is prevented from being seen anywhere in this execution. So what happens is that I just get into my condition over here. Oh, sorry, not the right instance. So I'm not going to get anywhere else, because what's going to be, it's going to be this condition here. So my input key is not going to match the control key. Fine. But at the same time, I'm not showing my secret anywhere, even if I don't have that key handy. So if by any chance I was going to see this is my key anywhere, it would have been a big problem. But it's just not going to happen. So you're not going to leak your credentials anywhere. Any question up to now? I'm just taking a look at the chat and taking a look at the Q&A.
Are we all good so far?
All good. Okay. This is an extremely powerful tool, though, because it completely prevents one of the most common issues, which is secrets in version control. That's extremely powerful, and I can totally recommend it to everyone. The next step will be starting to introduce some of these tools directly into your CI/CD pipeline. So let's take a look at a few examples. Again, in conscious of time, I'm not going to go running through them all from scratch, but I'm just going to show you something like this. So in this case, this is a build that is failing because it's finding credentials directly into the version control. So there is a simple fake class that I created, called secret class without too much imagination. And you see, I have some tokens and I've got a principal secret, all random strings, of course. But then my credential scanner is going to be able to identify what the problem is. And I selected the option of failing the build directly when the analysis is failing. So there is a failure because there are passwords in that file. So this scanner is able to identify them and provide me with a very nice report that's going to tell me, look, you have credentials at this point in time. Let me open that. This is the result. So today I scanned this. This is the file, and there is a 99.9% matching on that specific problem. And it points at line number 8 because this is a well-known, example of being a security issue and being a token, but it is also able to identify all sorts of tokens. So passwords, PATs, Azure Active Directory, secrets, and so on. This is an extremely powerful tool, and it's going to help so much teams which maybe they have legacy code bases, maybe they have stuff that they inherited. There is all sorts of things like that out there in the wild. Another tool that can be added is very effectively SonarQube. I'm a very big fan of SonarQube, and the way that it works is just by creating, obviously, a server somewhere, but then you can add your SonarQube scan by preparing it. So you prepare it, you point it at a well-known server, you obviously explicitly call out the scanner mode, which can be MS build, can be a command line, and so on. There's a project key, there's a project name, all regular stuff. Once you run it, then you can run your build, you can run anything else you needed, and then you will analyze it after you pass the point that you're interested in. So you can run your SonarQube analysis on your code, and then you can publish the results. The results are going to be in a nice dashboard like this, which is going to tell me that in my project, and bear in mind, this is a hello world type of project. Okay, this is an application that's literally the ASP.NET Core MVC hello world. Nothing more than that, but still, there are 12 bugs that are identified, mostly in external dependencies, as you can see, but still, stuff that's identified as a bug. Then you will have potentially vulnerabilities, luckily not. You will have security hotspots, so things that might be unsafe for any specific reason, or other examples, weak cryptography. Those are things that might be flagged as potential risks, potential issues, not explicitly as a vulnerability, but it's about knowing that in advance and making sure that those are fixed as soon as possible. So to the left-hand side as possible. And then obviously you can break the bill. So if you find something that you think is going to be a major issue, like the lack of coverage, rather than any specific security vulnerability, then obviously, if you have a critical thing, for example, that's something that you can break the build on. And it also provides you with some recommendations. So if you look at this specific thing, it asks, why is it an issue? Well, the issue is because of this reason. So it's very handy for a development team to have something like this that runs on the back of the CI build, and it's going to produce something that's easy to consume, obviously indexed, so you can definitely go into the code and look at line number 14 and fix it. That is extremely powerful, and it doesn't take too much to actually onboard, and it's going to provide so many benefits down the line that it's very difficult to say no to something like this. Other things that can be integrated at CI level is obviously anti-malware scan, which is, again, a simple antivirus scan, but also something like bin skim. So bin skim does binary scanning. Once your application is scanned, then it's going to provide you with a report of what is actually done. So in this case over here, everything is fine on this on this binary because there were no vulnerabilities. But this just runs in the background once you run it. So you have it as part of your CI. It is very quick, and it's going to tell you if there are well-known issues directly into your binary without going to the length of a 45 of a varcode or things like that. Obviously, you should not replace it altogether, but it gives you a very good head start when it comes to those type of security issues. And then other things that you can do is extremely powerful white source vault. It is extremely powerful because this simple task over here is going to run software composition analysis for your solution. So something like this, for example, which has failed, and it's fair enough, but at the same time, it's got white source vault running on it. So this runs against all your dependencies, and it's going to scan the version of the dependency. It's going to scan it against a well-known list of security vulnerability, and it's going to tell you what the problem is and how to fix it. So this is very powerful because I've seen that so many times. Libraries that are outdated, libraries that are not kept up to date, or they were just potentially just copied over rather than imported correctly via package manager. So many times, especially with legacy code bases, something like this is going to help out massively when it comes to actually maintaining your supply chain secure, because you might never know what's going to be inside your dependency. So the moment you take an external dependency, you're also taking on some responsibility on making sure that the dependency is safe and it is kept up to date. It also gives you an inventory, which is very handy, a list of outdated libraries, but also a licensing check for risks and compliance. So some licenses are more restrictive than others. Some licenses require more attention than others, and having these kind of scans done on the background, again, as part of the CI process, is going to make everybody's life easier, because if you have a red over here of a license that's potentially difficult to deal with or not compliant with what the organization might need, it's going to be way easier to fix when the application is being developed rather than after the application is live. And this is the same, it is the same point all over again, right? The cheaper, the sooner you get it, the cheaper it is to fix it. But again, it's important to have those tools, and those tools need to be lightweight. You don't want another tool to set up with their own servers, their own installations, and so on. You just want something that you add to the pipeline like this, and then that will be it. You don't have to do anything else because it's going to run in the background. And eventually, whatever you do, then you will have a nice report and potentially some files being updated with the content of the report. That's going to be always very handy because it's going to tell you that you have something to action and you can use it as a baseline to actually remediate on your problems. Those are a few things that you can do in a CI stage, but then when you move on to the actual deployments, then you have other things that you can do. You can do security security verification testing, for example, and you can do it both as part of the infrastructure as code process, but also as part of the existing environment. So, for example, if I look at something like this is a SVT test. Well, this is OWASP. Apologies, I picked up the wrong one. You have other ones. Oh, let's run it again, shall we? So if I run it on the ARM template, my SVT, that's going to run against the definition. So my application is obviously going to be built fairly quickly. In this case, I didn't run as many tests over here. And then the same application will have an infrastructure as code deployment to make sure that the environment is kept up to date, and then a deployment itself. But let's take a look at what's going to happen here, because I think it is quite interesting from a development point of view. So what happens is that if I want to run SVT as part of my application build, then with your ARM template is going to run as part of your CI because you're doing infrastructure as code, and then it's going to check against your well-known definition. So your ARM template, in this case, is going to be scanned for well-known patterns of security problems. So again, you will have a very strong baseline, but in a nutshell, this ensures that your infrastructure as code definition is secure well before your environment. So even if you deploy the environment already, if this infrastructure as code definition doesn't meet all the baseline rules, then it's going to be rejected. There's going to be a failure in the build, and that's again to prevent the infrastructure from being compromised, prevent the infrastructure from being deployed incorrectly, and so on and so forth. It's going to take a few seconds, but this is going to run again at the template level, so it's not even going to reach the staging level. In the meantime, let me run the same test, but with the SVT on the environment. So let's go back to this, and here we will see that in a moment. After the build phase, will be a package, of course, very quick. It's just a zip file, and then it's going to go on the ARM template checker. So what's going to happen here is that this task is going to scan your ARM template. It's going to use a ZSK that's available on the relevant Microsoft website. It installs the module on the fly, and then it's going to scan it. The nice thing is that you will get a report of this, which is going to tell you what's going to be the severity of the problem that's found. So it's going to be easy for anyone to actually action those rules. So I'll take a few seconds here just to install. Got too many permutation of demos, so it's going to be easier to just rerun it off from scratch. The reason why the module is always installed, by the way, is always to maintain it fresh and making sure that it never goes stale, and it also doesn't get compromised. So it is also installed on the fly on your agent, regardless of a hosted agent or private agent. In case you're wondering while we wait for it, AZSK is available on GitHub, and it is also available on its own website. So you can search for the secure DevOps kit for Azure, and you will find how to install it, how to configure it, and how to put together the whole end-to-end loop. Still installing though. So this is the loop for secure DevOps. You start with the subscription itself, which needs to be configured with Azure policies, alerts, the correct role-based access controls in place. And then you start adding things like SVTs for environments and following up SVT for CI/CD, well, for the ARM template rather than the environment. After that, you will watch production and scan it for drift, and you will have analytics, alerting, monitoring, and then governance on top of it to make sure that there is, whatever decision is made for the security of the platform is made with data-driven decisions rather than the flavor of the day. Still installing over here. Pretty slow, right? But what's going to happen is that you will, if you install this, you will add the Azure DevOps extension for that, and it's going to allow you to do this SBT test. So let's take a look. There is a link here. So yeah, you can install it, and then you can install the extension. The extension, again, it's all available. So it's all stuff that you can sort out on a self-service basis. Nothing else to do really on it. You just open it, you install it, you get it on your organization, and you will be able to run security verification tests directly from your pipelines. Okay, it is running now. So you can see that failures all over the place on my ARM template. So that's going to be stopped, and I will have a total of 14 controls to make, and pretty much all of them fail except for this specific one for the app service. You have something like simple like do not allow HTTP access, as well as use a secure revision of TLS, or configuring WebSockets and remote debugging in the right way, so usually disabling and so on. And this is done at ARM level, so this is done as part of the definition, but you can also do it as part of your environment validation. So this is obviously going to take a minute or two, but if we go back to this graph over here, you can do it also as part of your environment. So doing it at CI/CD level, brilliant, because it's going to prevent problems from reaching the environment, but you should also be able to understand if your environment is configured correctly. So if your environment has got well-known problems or things that have been flagged as security risks. So this is obviously going to take a few minutes, but when it comes to the actual infrastructure as code, then you will see that, let's take a look at the pipeline itself. You will see that over here, if I run the SBT on the environment, before running ARM, then I'm going to check for my environment against my well-known environment on a resource group, of course, and then this is going to run the same test against a live environment. If that test will fail, of course, it means that you have something in an environment, hopefully not production, that's not configured is not configured correctly compared to the baseline, so it needs to be fixed. So let's take a look over here. Just going to go now onto the right stage. It's going to take it up in a second, and this is going to be the first job that's going to run. So this is going to start, and the first thing that it's going to do is going to be SBT. So it's going to run security validation against a live infrastructure environment. I had very poor luck today with performance, unfortunately. But yeah, that's going to run exactly the same type of test. But the important thing is it's done against the environment. So it's done at resource group level. You usually map a resource group per environment, so you can definitely do that directly in your pipeline. It is going to take a few minutes, so let's quickly go over here. You can take a look at what it is actually doing. So when it comes to CI/CD in particular, that's what this is what the task can do. It can also be added to Jenkins. So worth mentioning that you don't have to use Azure DevOps per se, but you can also go with Jenkins. Or effectively, if you get the right module, you can also use other engines. But at the end of the day, support is there for Azure DevOps and Jenkins. Moving on from here, you should be able to see that in a moment, but I think we should just move on, and I'll go back to it in a second. Moving on from here, you should look at dynamic testing. You should look at system security testing. So you should look at things like OWASP ZAP. OWASP ZAP is very well known. Oh, I should take that. Was over here, I think. Yes. So OWASP ZAP is very well known for being an open source product that's going to run dynamic system tests against live applications. So you can definitely integrate it, and you can run it as part of your deployment job. because whatever is going to happen, you will have it over here. So if you run OWASP zap, you will just start a new container that's going to target your application. Obviously, I just hard-coded the URL over here, but you can bring URL outside from a variable or anything else. And then you can just run the suite you are interested in against your application. So let's take a look at the live pipeline as we're talking about that. So if we edit this over here, we have, yeah. So this is going to run against my live application. It will have a failure threshold, so that there will be warnings, there will be errors. It's important to set a sensible threshold. I set it to 150 just to get, to get the successful scan, and then the port, of course, so port 443 for HTTPS. Once this is done, that's going to generate a unit template result. So I'm going to run this command to just generate the attachment and generate the file that's needed for all the test results. And once that's done, I will generate the test results, upload it into the XML template, and then populating it. Once done, it's going to be populated into Azure DevOps. The result of it is what we've seen here. So I'm going to generate my template. It's going to generate the test result. It's going to populate it, and then it's going to upload it to Azure DevOps. But it is going to fail because I set my task to fail on failed test. So whatever the test is, if it's going to fail, then it's going to fail the whole deployment, and that's how it should be done. So you don't want to get to a green deployment with failing test. And the nice thing is that it is integrated with Visual Studio Test. So if you look into it, you go into the test tab here. Oops. Go into the test tab over here. You can see that those are the tests that have been run against the application, like this one over here, and it's going to tell you what is the problem, what is the instance that this problem is happening on. Obviously, you have all date and time information. If you use Azure DevOps properly, then you also have traceability at environment level. So you will be able to identify on your environment what is the actual environment that's causing issues. And if you go into the environment, of course, you will be able to trace what are the various applications that have been causing issues. So you have an end-to-end traceability story over here that you can leverage on pretty much anything. And if you run OWASP up, you can also run it against live production applications before you get onto the, onto the actual live usage by switching over potentially a load balancer or a traffic manager or anything else. So that's going to show that your application in production is kept as secure as possible. That doesn't obviously replace tools like Fortify, Veracode, and the likes, but obviously helps because it is lightweight. This is done just by literally running. So this is in the meantime the failed environment validation that we were talking about before. We'll see that in a second. But what's going to happen is that this job over here will be run against the container. So this is going to pull a container down on the fly from Zap to Docker stable. So you don't have to worry about anything really. You just run the container with the test in there, with the scanner in there. It is extremely powerful, and it is going to run easily because again, it's nimble. So it only took in this case 1 minute and 8 seconds. Back to the scenario we were talking about earlier about environment validation. Again, same story over here. It took a little bit of time, but I know that that application is vulnerable, and this is done as part of the validation for the environment. So in this case, it's going to check against a well-known resource group in my subscription, and it is going to check for the same baseline, the same security baseline that we use for the ARM template. Any question? It's been a lot, I reckon.
Now it seems that everything's so clear. No questions yet.
Well, if you have questions, you can follow up offline. That's not a problem at all, of course. But summarizing, remember that you have those 4 quadrants. So you have examples for all of them. So if you go onto the caller ID tools, you can use DevSkim, you can use SolarLint. Unfortunately, DevSkim didn't seem to work tonight, I need to investigate why. Then you have build tools like White Source Bolt, SonarQube, or the security code analysis kit that I use with CredScan and BinSkim and the anti-malware. You have orchestrator tools like AZSK, again, the security code analysis toolkit, and DAS tools like Fortify Checkmarks, ZAP, and so on. And eventually on the monitoring side, as you monitor, that's a given, but also AZSK again, because you can set up continuous monitoring and continuous assurance against your live environments. Slides are already available on SlideShare, and for any question, feel free to reach out.
All right, sounds good. So, do we have any questions? No, it doesn't seem so. All right, so thank you very much to Matteo. Thank you for the last session. It was super useful and interesting, and yeah, we are going to put the recorded session in our YouTube channel by the end of this week. And if you have any questions, you can ping Matteo on Twitter. And thank you very much, everyone, for participating. And by the way, we do have one question from Tim. Are the free tools good enough, or do you recommend any commercial ones?
So the free tools are definitely good enough, but there is no 100% end game, in the sense that you need to tailor your security solution based on what you actually need. So you should obviously go incrementally, start adding things step by step. And some of them are very easy to do, like White Source. Some others are a little bit more tricky, like the Secure Code Analysis Toolkit. And then you have commercial solutions, which are extremely good as well. So it's about balancing the needs, the requirements, and the actual overhead that you want to introduce at a certain point in time. All of the things that I've shown tonight, aside from the Security Code Analysis Toolkit, they are all available freely on the internet. There are community edition for SonarQube and SonarSource. And SonarCloud. The AZSK toolkit is available and it is free. Also, DevSkim is free. Key Vault is a service in Azure, so you can definitely do a lot with just free tools. Brilliant question.
Okay, thank you. And as we don't have any more questions upcoming, so Matteo, thanks again. Thank you for staying this Tuesday with us. We learned a lot, and we hope so to have you sometime next year.
Hopefully so. Cheers, everyone. Bye.
Thank you. Bye-bye.